Very good morning. Welcome to the third lecture of the 7th week. We will continue decomposition of total sum of square and cross products. Today we see one-way MANOVA table and hypothesis testing, related hypothesis testing with an example. I am sure you are enjoying the lectures. Let us see what is there in the next.
We will continue MANOVA, Multivariate Analysis of Variance. What we have seen in last class, that we have decomposed SSCP total into two parts, SSCP between population plus SSCP error. And we have also discussed that the degree of freedom for SSCP total is n minus 1, where n is equal to L equal to 1 to capital L n L, and there are L populations. So, the degrees of freedom for SSCP B is L minus 1 and rest as the total of SSCP B and SSCP each degrees of freedom will be n minus 1. So, the rest will be n minus L. And as I told you in last class that SSCP B will be computed using this formulation L equal to 1 to NL XL bar minus X bar and XL bar minus X bar transpose, and SSCP E will be computed using this formula N1 minus 1 S1, N2 minus 1 S2, like up to NL minus 1 SL, and then SSCP T will be the sum of these two, this equation. Okay. So, now let us see one problem what we have discussed in last class, that there are three processes A, B and C, and we have sampled 10 observations from all the processes and two variables, outer diameter and inner diameter, and you see the mean values for process A is 20.20 and 6.50. So, if I write the mean values here, then for process A that mean value will be 20.20 and 6.50. Similarly, for process B it is 17.90 and 6.70. And what about for process C, that is X3 bar, this is your 20.60 and 7.50. Now, what will be your X bar? X bar will be N1 X1 bar, N2 X2 bar plus N3 X3 bar divided by N1 plus N2 plus N3. Now, we have N1 equal to N2 equal to N3 equal to 10. So, we can write this one as 10 X1 bar, X2 bar, X3 bar by 30, which is 1 by 3 into X1 bar plus X2 bar plus X3 bar. So, what will be this quantity then? 1 by 3 X1 bar is 20.20, 6.5 like this. So, your case will be 20.20 plus 17.90 plus 20.60 second one will be 6.50, 6.70 plus 7.50. If you add all those things, 20.20, 17.90 and 20.60, quantity will be 58.70 divided by 3, it will be 1, 9, 27, then 17, then 5, almost 7. So, this quantity will be 19.57 and second one will be 6.5 plus 7.5, this is 14 plus 6.70, this is 20.70 divided by 3. Okay. So, this will be 6.90. So, this is 6.90. Okay. What more we want? We want to know what is S1, and in last class you have computed S1 is 1.51, 0.11, 0.11, 1.17. Your S2 is 1.43, 0.52, 0.52 and 0.68, and S3 is 0.93, minus 0.11, minus 0.11 and 0.72. Now, we want to calculate SSCP B first. SSCP B. If you require to calculate SSCP B, you require XL bar minus X bar and its transport to be multiplied. So, I am writing the formula. First, SSCP B as N1 equal to N2 equal to N3 equal to 10. So, I can write like this, your L equal to 1 to NL, NL is basically N1 to all those things, NL, that is the formula, XL bar minus X bar, XL bar minus X bar transpose. So, we will first consider, I think we have done a mistake, L equal to 1 to L, capital L, this is the capital L. So, our L equal capital equal to 3. So, you will be getting 3 sets of values here. First one is N1 x1 bar minus x bar, x1 bar minus x bar transpose plus N2 into x2 bar minus x bar plus x2 bar minus x bar transpose plus N3 into x3 bar minus x bar and x3 bar minus x3 bar minus x bar transpose. I will show you one calculation, first one, and then similarly other also will be computed. Now, our x1 bar, if you see what is our x1 bar, here you see x1 bar is 20.20 and 6.50. So, 20.20, 6.50 minus if we want to do x bar. So, I can say that this minus x bar equal to our x bar value is this 19.57. This is also a matrix of order 2 cross 1. Okay. So, then this quantity we can write x1 bar minus x bar is 20.20 minus 19.57. So, this is 36, I think 0.63. Second one will be 6.50 minus 6.90, this will be minus 0.40. So, what you require? You require to calculate x1 bar minus x bar into x1 bar minus x bar transpose. This is 2 cross 1, this is 1 cross 2, your resultant matrix will be 2 cross 2, and that is what you want. So, I can write like this now, 0.63 minus 0.40 into 0.63 minus 0.40. The resultant matrix will be 0.63 square minus 0.63 into 0.40 minus 0.63 into 0.40, then minus 0.40 square. Okay, please see that these are square matrix 2 cross 2 and symmetric matrix, because this portion here this equal to this. In similar manner, you will be getting x2 bar minus x bar, x2 bar minus x bar transpose, and x3 bar minus x bar this transpose. So, now the what will be the resultant value? Resultant value is this, n1 equal to 10. So, this quantity will be 10 into, we have already found out the value, 0.63 square minus 0.63 minus 0.63 into 0.40 minus 0.63 into 0.40 minus 0.40 square plus 10 into whatever matrix value you get plus 10 into this. So, resultant, the ultimate thing, that SSCP what you get here, SSCP will be, SSCP B will be, we have computed, that will be your 42.47 and 7.00, then 7.00 and 5.67. So, SSCP B is calculated like this. Now, we want to calculate SSCP E. I told you this will be n1 minus 1 S1 plus n2 minus 1 S2 plus n3 minus 1 S3. In this case, L equal to 3, capital L. So, we will go by like this, and n1, n2, n3 all equal to n equal to 10. So, this is nothing but 10 into S1 plus S2 plus S3. So, I will write down now equal to 10. What is our S1? You see, our S1 is this, S2 is this, S3 is these 2 cross 2 matrices. So, you write down. So, S1 is 1.51, 0.11, 0.11, 1.17. So, plus 1.43, 0.52, 0.52, 0.68 plus 0.93 minus 0.11 minus 0.11, 0.72. This is your SSCPE, and if you see that 1.51, 1.43 and 0.93, this you, if you add, what are the values you will be getting, that 15, 14, the 29 plus 9, almost 33 point something you will be getting. So, this resultant quantity will be your 34.90, 4.70, 4.70, 23.10. Okay. So far what we have discussed, if I recapitulate again, I think this is the computation part we are considering, that we said that in a MANOVA, in one way MANOVA, the SSCP total is decomposed into SSCP between population and SSCP error. And we also have seen that the degrees of freedom is n minus 1 for SSCP total, L minus 1 for SSCP between, and SSCP E is n minus L, and these are the formulation. computational formula for SSCP B and SSCP E. Then I have given you this one. This is the problem. What I said that let us compute SSCP B and SSCP E for the data set given. For this, what you have done? You have to first find out what are the mean vectors, and these mean vectors are like this. These mean vectors are x1 bar equal to 20.20, 6.50. This is a 2 cross 1 vector. 17.90, 6.70. This is also 2 cross 1, and x3 is 20.60, 7.50. This is also 2 cross 1. Using these three vectors, mean vectors, you have computed the grand mean. You have already computed the grand mean. The grand mean is n1 x1 bar plus n2 x2 bar plus n3 x3 bar by n1 plus n2 plus n3, and in our case it is equal sample size case. So, finally, it goes to this one, that x1 bar is 1 by 3 times the sum of the three mean vectors, and as resultant value is this. So, our grand mean is 19.57 and 6.90, and then we computed SSCP B using this formulation. SSCP B is L equal to 1 to L, capital L, NL into this, and SSCP E is this value. Now, from computation point of view, what we have seen, that I have shown you one computation, because the SSCP B part, if you see, it is basically sum of three different elements. Those three different elements are like this. Three different elements, that is n1 into this, because see, it is sum total of this, L equal to 1 to capital L. So, our capital L is 3. So, if I put L equal to 1, then this is the quantity. If I put L equal to 2, then this will be the quantity. If I put L equal to 3, then this will be the quantity. Our case is equal size case. So, n1, n2, n3 I am putting 10, 10, 10, then you are computing this one. How we are computing this x1 bar minus x bar, x1 bar minus x bar transpose, that one computation formulation I have shown you, and this formulation is like this. First, your x1 bar is this, x2 x bar is this, the difference will give you x1 bar minus x bar. Then x1 bar minus x bar and its transpose, this is what you have written. So, it is a 2 cross 1 matrix, this is 1 cross 2 matrix, you will be getting resultant 2 cross 2 matrix. So, 0.63 into 0.63, 0.63 square, 0.63 into minus 0.40, this will be the value, then minus 0.40 into 6.63, this is the value, and minus 0.40 into minus 0.40, this is the square value, and the resultant values are like this. So, for the first one S1, no, this SSCP, resultant values is this, where all three parts are added, parts related to this component, this component, this component, when added you will be getting like this. Then what we require to know? We require to know what will be the sum square cross product error matrix. The formula is, it will be the sum total of n1 minus 1 is 1, n2 minus 1 is 2, n3 minus 1 is 3, because we have 3 population, n equal to 10. So, our value is like this, and we have started with this, that our S1 is this one, S2 is this matrix, S3 is this matrix. So, you are adding 1.51 plus 1.43 plus 0.93, this will be nothing but 3.49, and if you multiply it by 10, it will be 34.90, and similar manner you are getting SSCP E. So, what we have now with us? We have SSCP B matrix, which is 42.47, 7.00, 7.00, 5.60. you have SSCP error matrix, which is 34.90, 4.70, 4.70, 23.10. So, you know your SSCP total now. This plus this resultant will be 77.37. Now, 7 plus 4.7, 11.70, 11.70, then 23.10 plus 5.60, it will be 28.70. Okay. This is the decomposition of total matrix, this equal to this plus this, or this equal to this plus this. Okay. So, in ANOVA you have decomposed SST, sum square total equal to sum square between population and sum square error, and in MANOVA what you are doing, SSCP total is decomposed into SSCP between plus SSCP error. So, because of more than one variable, your computation will be in the matrix domain. Okay. Once you decompose the SSCP into the parts, you are in a position to calculate the MANOVA table. Please remember, this is one way MANOVA. We are talking about one way MANOVA because we have taken only population of some kind, one kind, that population 1 to population nil, not some other kind of factors are considered. This table, in this table you have to write down what is the source, similar manner, sources of variation. So, definitely your population is one source, then error is another one, then total is coming. Then you have writing SSCP matrix. So, our case is SSCP between SSCP error and SSCP total. Then you will be writing degree of freedom, and I told you that n is sum total of L equal to 1 to capital L NL. This is the case. So, in that case our degree of freedom for total will be n minus 1, for SSCP B L minus 1, and this will be n minus L. Then in ANOVA you have found out the mean square, between mean square, error, all those things. Here we will not use like this, we will create a matrix called Wilks lambda. Wilks lambda, this is basically a ratio. Okay. This Wilks lambda ratio will be computing, where Wilks lambda is determinant of SSCP error by determinant of SSCP total. Okay. And what we want that the SSCP error, this determinant must be as low as possible compared to the total. So, this quantity will be as low as possible. Okay. Or other way you can say as small as possible, and but there are certain distribution available using Wilks lambda, and if you go by multivariate books you will be finding out that different combinations, different sampling distributions are available. We will show you a general one in this class. Okay. Now, using this, whatever we have developed so far, based on this we want to test the hypothesis. What are the hypotheses? First hypothesis is null hypothesis and alternative hypothesis. In our case, null hypothesis is there is no difference in the mean vectors for all the populations, and alternative hypothesis is at least one pair of populations are different in terms of their mean vectors. You will use a statistics, this statistics is minus within bracket L equal to 1 to L n L, this is capital N minus 1 minus p plus L by 2 log lambda. Okay, lambda, you know that how to compute lambda. Then this statistics follows chi-square distribution with p into L minus 1 degrees of freedom. Okay, so then what is our statistics? Our statistics is that n minus 1 minus p plus L by 2 log lambda, that is Wilks lambda, and what we are saying, this follows chi-square p into L minus 1. What will be your decision? Decision will be, if I think this minus is one minus is there, because Wilks lambda this is a low value, keeping minus here we are making it positive. So, our hypothesis is reject H0, that means no difference among the population mean vectors, if minus n minus 1 minus p plus L by 2 log lambda, this value greater than chi-square p L minus 1. You will reject null hypothesis under this condition. Okay. Now, we will see for the problem given what is the status. You see the slide. So, SSCP B we have already computed 42.4770 like this, SSCP E is also computed, SSCP total is also computed. Our capital N is 30. So, this degree of freedom I hope there will be no problem, 29, 27 and 2, and then state statistics is lambda, and if you compute determinant SSCP E, this one 34 into 23.10 minus this square, you will be getting 784.10, and total case you will be getting this one 77.37 into 28, this you will be getting this one. Okay. So, your determinant of SSCP is 780.10, determinant of SSCP total is 2083.54. Now, if you take the ratio, you will be getting lambda equal to 0.38, correct. Now, what will be the log lambda? So, our statistics value will be minus n is 30 minus 1 minus p is 2 plus L is 3 by 2 log of 0.38. This one will be minus, this is 29 minus 2.5. So, that means the resultant will be, this resultant will be 26.5, okay, into log 38. You find out this value. I think the resultant quantity, this will be 11.25. Now, you require to find out what? You require to find out chi-square p L minus 1, p is 2, L minus 1 is also 3 minus 1, that is 2, and you have to take a alpha value, let alpha equal to 0.05. Then this one is chi-square 4, 0.05, this value is 9.49. So, statistics value is more than the tabulated value. Your case is coming like this. This is my tabulated value 9.49 and my computed value is here 11.25. This is the zone of rejection. Okay. So, null hypothesis is rejected. Or we some says failed. No, this is null hypothesis is rejected. There is alternative hypothesis that there is some difference among the population means.